This is going to be our second last video on log equations, and then we're going to move on to real life logs. But anyway, yeah, so this equation, or this question, is really like an index equation. It's the same as video number 4. So if you go back to look at video number 4, so I'm going to skip through this, as in not skip through it, but I'm going to go through it quite quickly. And if you're confused about the method at the start, then I'd recommend looking at video number 4 again. And the log's going to come in here at the end. So anyway, I'm just going to jump straight into it. So 2 to the power of 2x, we can break that into 2 to the power of x squared, and minus 2 to the power of x plus 3, we can break that into minus 2 to the power of x multiplied by 2 to the power of 3. Okay, that's 15 is equal to 0, so that's the first rule of indices, just kind of going backwards. So this is going to stay the same, 2 to the power of x squared minus, this is going to be, I'll say 2 to the power of x multiplied by 8 plus 15 will stay the same. I'm just going to write this all, so 2 to the power of x squared minus 8 by 2 to the power of x plus 15 is equal to 0. So now we're going to do what's called a substitution. So you might see this looks like a quadratic. You have 2 to the power of x squared minus 8, 2 to the power of x plus 15. So if we let 2 to the power of x equal to u, then here we have u squared, so u wherever 2 to the power of x was, minus 8 by u plus 15 is equal to 0. Does that make sense? So now we can solve for u instead of 2 to the power of x, because that's a bit awkward. So then here we're going to have u minus 5 and u minus 3 is equal to 0. That means u is either equal to 5 or u is equal to 3. If we want to look at that there, that's going to give us 2 to the power of x is equal to 5. That's a bit messy. Or 2 to the power of x is equal to 3. So now we have to deal with these. But as you can see, this won't be as simple as the end of the question in video number 4, because there's no even whole number that you can stick into x here to find 5. So 2 squared is going to be 4, and then 2 to the power of 3 is 8. So it's going to skip both of these. So you're going to have to find a decimal place, and the way we're going to do that is we're going to do that with logs. So I'm going to scroll down here to do that. I'm just going to write 2 to the power of x is equal to 3. Okay, so this is, I'm just going to start an important method. So this is quite important now for real life logs. This is going to be the same kind of method we're going to do every single time. So you have a power here you want to get rid of, and you want to find out what the x is. So in the intro video, we did kind of a way where you can write it in one line basically. So if you can try to rearrange these in your head, you can find out what x is by finding log of 2 and 3 in some order. But that's not basically the best way to do it, just because it can be more confusing, especially when you get to harder questions. So this is definitely the method you should do, because you can apply it to anything and there's no rearranging in your head. It's much more definite. So basically, because there's a 2 here and it's 2 to the power of x, we're going to take log to the base 2 of both sides. So I'm just going to say that. Take log of both sides. Okay, and you can pick any base. So I'm going to say to the base 2, and that's because it's 2 to the power of x here. So it's going to be log to the base 2 of 2 to the power of x is equal to log to the base 2 of 3. Okay, log to the base 2 of 2 to the power of x. So either you can remember that's one of the rules, I think it's rule number 6 or something. That's just equal to x, or else you can bring it down in front, multiplied by log to the power of 2 by 2, and realize that that's equal to 1, this here. So just 2 to the power of 3. So basically x multiplied by 1 is just x, and you have log, or x is equal to log the base 2 of 3. Okay, so that method's really important because you can do it with any combination of numbers, letters, anything like that, to find any power. So it's just about multiplying, or taking the log of both sides, and ideally one that will cancel here, so it just makes it a bit easier, and then finding x. So then after this, it's just about putting it into your calculator. So I'll do that in yellow. The answer is going to be x is equal to 1.588, I think. I'll just leave it at 1.58, and you can put as many decimal points as you want. So then quickly, I'm just going to do the same for u is equal to 5, or 2 to the power of x is equal to 5, but it's going to be the same method. So 2 to the power of x is equal to 5. So you guys should try and pause the video now and follow the same steps here to try and get this one. So I'll take the log of both sides, and again I'm going to use base 2 of 2 to the x is equal to log the base 2 of 5. So again, for the same reason, it's going to be x is equal to log to the base 2 of 5. Stick that into your calculator, you'll get x is equal to 2.32. And again, you can put as many decimal places as you like. So that's all for that video there. So again, that's just an indices equation, so index equation, really similar to what we had in video number 4. But in video number 4, we made it so that the answer at the end was a nice handy one. It was you could figure this out in your head. You didn't have to use logs at all. But if you do get ones like this and there's not a nice answer, you use logs. So you could get one nice answer, one not nice answer. You have to use logs and indices. But anyway, that's that one. And again, yeah, this method is really important. We're going to use it a lot when we start talking about real life logs, so make sure you're comfortable with it. Okay, we'll see you in the next video for one last log equation.